Good afternoon, everybody. Thanks for coming out for today's session. Can everybody hear me properly? Okay. So today I will be presenting the way how we deploy the Tableau in Electronic Arts. It's one of the top gaming company in the world. So our journey started way back in 2012. So we started the Tableau from the version 7. So currently we are on the latest 8.1.6, I believe. So we are planning to go for 8.2. So I believe once you guys walked out of this room, I'm pretty sure that you guys should be able to build an enterprise platform at anywhere, any company. So let me give you a brief background about me. So I'm working for Electronic Arts from 2011. It's been 3 years. I love gaming industry. So I love playing and working at the same time. So some of the best games are like Battlefield, Titanfall, These games are my favorite ones. Similar, before that I was working at the Home Depot. I did a lot of consulting. I worked for Wells Fargo. I used to do the consulting at KPMG and Accenture. So I worked in all different kind of industries. So let's talk about the agenda. What I'm going to cover today. The first thing is I will give you a brief description what kind of analytics we do at a gaming industry. The second one is what was our vision, why we went ahead and built a Tableau at enterprise level, what was the objective behind that. And the third one, I'll talk about our Tableau ecosystem, how big our system is, how we managed it. The fourth one is I'll talk about the security management, how we can secure the data, how we rolled out at the enterprise level. Being a Tableau is not an enterprise tool when we introduced it at the company. So how we went to that journey, that's what I'm going to talk. So then I will talk about the Tableau architecture, failover recovery, backup and maintenance strategy, monitoring and alert. At the end, I will be giving some tips. Probably it will help you guys. So let's talk about what kind of analytics we do at EA. I think it's pretty common practice in any company in the world. So I believe we follow the same thing. So as everyone knows, everybody has standard reports. So that's the basic thing. If anybody wants to create anything, they just go create a bunch of standard report, static reports, and they'll roll it out. Similarly, we have once the business got involved into that, the requirement will go deeper, and it will get into the ad hoc situation. People want to do too much ad hoc requests, then it goes into the drill down mode. They try to see the data, how it is behaving. Then we do have the alerts. So this alerts is a pretty interesting one in any industry, especially when it comes to business. So if anything goes wrong with the sales, or if there's too many people are playing in the game, these are the alerts we get to make sure our servers are running up and running. It's able to support the game servers. So similarly, we do have advanced analytics like statistical analysis to see what is happening and what are the opportunities we are missing. So with respect to the competitors, and forecasting, it's what's happening now, how it will happen in the next six months or a year. Forecast, and I measure it against that. The next one is predictive modeling. This is the very cool feature what we do at EA. This is very important for a gaming industry where we release certain game, we want to see how it can behave when we go for the next version. How the people are responded to the older version. What can happen, and what was the load on the previous game title, and how we can build a next set of environment so that we can support the usage of the game. And the last but not the least is the optimization. This is the pretty cool one too, where we try to see how in what way we can optimize the pricing, especially in the gaming industry. Nowadays, freeform model is becoming pretty popular, but we do have some of the games where everybody play on the consoles. Usually it goes by $60 or 70 pounds. So the data what we provide is it will try to analyze and see what is the value we try to come out of when the customer pays $60. So we'll try to evaluate and see in what way we can optimize the price for a particular game. Whether it could be a free-form model or it could be upfront paying $60. There's different way how we do come up with a bit of microtransaction and we determine what is the best option to keep the gamers happy so that they can keep playing. We can monetize on top of that. So let's talk about the next one. So vision. So why we built this platform at EA? In the beginning, way back in 2010, Before I joining the EA, like a lot of silo system was running across the EA. All the gaming company, being a technology company, each and every studio people, they're like top class technology people, and they know what they are doing it. So they upfront they went and they bought Tableau and they started working using it like upfront. Or we have more than 10 studios across the world. Everyone has Tableau at that time, and nobody knows what each other is doing. So when it comes to the situation, like when the new CTO take over the EA at that time, like he moved from Microsoft, his name was Rajat. So he decided, okay, all these silo systems are running in each and every individual studios. How do we integrate all these things so that people will know each other what they're doing it, so that they can share the knowledge, they can say the way how they are doing analyzing data. So that's where I came into the picture. Like I joined in 2011. I took this opportunity to build the system. So once we started analyzing like how this silo system being used by these game studios, I was trying to understand like what is the objective behind that. Why people are so passionate about this new tool Tableau. I was a MicroStrategy fan like for 10 years. I didn't know nothing about Tableau. I was like curious why these people are so much passionate about this. The cool thing is, the people in the game studios, they build the game, that the new IPs, which nobody knows what they are doing it. And they want to see like how it can react, like by running the beta analysis and all, so that they can have more control on their data and visualize that what they are doing. That was one of the key objectives I came out of, saying that, okay, we don't want to get into any enterprise level where where they will have a lot of process in place. You know, we are in a data-centric organization where they want to make the decision upfront. So they want to build a new version of a game. They have the data, they analyze it using Tableau, boom. They know what they have to do next. And on top of that, like we do the beta analysis a lot. We try to understand like how the beta users are behaving with respect to the game, to decide like can we add any new features? You know, is there any better way we can improve the game so that we can get into the final rollout? These are the key things the game studios teams does that. Since we were able to give the control to the analyst and the business, like everybody wants their own thing. Like each and every game studio, they have their own control, but they run everything on the single platform across the IEA. The reason for that, we gave them the full control. Okay, you do whatever you want to do, but we will be, being an IT organization, we will control how the data will be on the platform and how stable we can maintain that so that we can provide a SLA defined by the game teams. Let's talk about like how is our ecosystem at EA. So currently, we have more than 1,100 workbooks. On a weekly basis, it goes more than 20 workbooks. We have more than 6,000 views, like reports, and it keeps growing every month, at least 500 views. Data extract, we extract the data, almost 1,000 workbooks on a daily basis. And it keeps growing by 50 every day. The reason why the data extract we have too much is like we run in a gaming industry where the live data make more sense. You know, like in Tableau, like people nobody cares if it is stale data. They want to make sure the data is up and running every time. So we have too many extracts so that we can keep track of the real-time scenario, how the gamers are playing and what kind of customer service we are providing, so that we can give the better experience to the gamers. You can see the total active users, we have over 1,000 users on a yearly basis. Being in a game industry, like whenever the new launch comes up, you know, we have a lot of users trying to understand the game, like what's happening on the sales front, on the in-game analytics, with the experience we are providing. All this end-to-end analysis will be active during that time. So on any given day, 150 on an average it will be. On any peak Monday morning, it might go 200 to 250 users, especially at 10 p.m. PST. We support more than 20 teams across the globe. We have studios all the way from Australia, Sydney, all the way to Japan. We have in South Korea, you know, we have, you name it. We have a day studio where we make the Battlefield, which is in Sweden. So we have these studios across the globe, and we support all this time 24/7. Means we need to make sure our server is up and running 24/7. If it goes like 10 minutes, somebody from some part of the world will be thinking, okay, this server is down, what's happening? So, pretty challenging one. So our ecosystem is so huge. Let's see, like, what was strategy we enforced people to adopt it at the enterprise level. For example, in this case, like let's see like what kind of data all these people does, right? People will be interested. So we do like sales, any basic sales reporting. So the next one is live games, site health monitoring. This is pretty cool one to make sure like our game servers are up and running all the time. If anything goes down and all, we have alerting system in place so that people will get the alerts. The in-game analytics, we try to understand like when any new game or old game is going on, we try to do the analytics within the game to understand how the people are playing, what kind of achievements they're doing, are they getting stuck anywhere, is there any way we can improve the game? Like if people are finishing the levels too fast, they might lose the curiosity. So they might leave the game and go into the next one. So we try to get that curiosity in place. The way how we do it, we try to understand how the people are playing in the game. If they're clearing the levels too fast, we know there's something wrong. We try to make sure it is more curious so that people can understand, oh, I'm not able to do that. Let me try again. If it is too easy, they'll just play it and leave the game. We don't want to do that. We need to keep the gamers curiously so that they can come back, play, and automatically convert into monetization. So the fourth one is user behavior analysis. This is pretty cool one, especially in any online companies. It could be Facebook or Google or EA. We are like an online company. So we are trying to get a customer on the publisher relationship directly. So we are trying to understand how the customer is behaving. So this analysis, like for example, how when we launch the new game, we try to understand how the people are coming when the new game is launched and what's happening within like next 10 days, 14 days, 15 days. We try to do like cohort analysis to see the group of users, how they are behaving with the game. So that we know like how the load on the server, how in what way we can provide the game server load so that all these gamers can have better experience. And also it helps for the marketing team to understand these are the cohort group, they are more valuable for the company, so that we call that as a whales reporting. So the next one is customer experience. Like we are trying to get into the customer experience more. Like we have a better understanding of the customer, like understanding customer issues, all this kind of stuff is pretty important for any company. So we have some of the reportings which will track of like how the customer support team is providing the service to the gamers, in what way people are having issues when they are playing the game, so that we can improve the experience that makes them happier so that they can play more. The other one is the campaign analytics. This is for any online or any general company. Campaigning is pretty cool thing where you work with the marketing team, try to come up with the campaigns and try to target the whale customers, or like based on the user analytics, we will define like what kind of segmentation of people are more interested for this new game, so that we can do the cross-selling within the game, or like cross-selling by understanding the user behavior between the games. The campaign analytics team will know like in what way they can promote the product. And also the price optimization also plays a key contribution here to see like in what kind of people can get a better price, so that we can make them playing more and more. The beta game analysis it's pretty cool and a new one what we introduced, where like if any new games are releasing, we try to release that to the people. Recently we released the Battlefield Online game, like we released that to the beta, like went more than 3-4 million people. The reason why we went is like to understand what the gamers experience, what their response to the initial beta version, to see how where the curiosity sits in. Can we release this or not? Like can we add a new feature, make it better? Those kind of analysis we do so that we can make the game better. Some of the dashboards what I'm showing here is like just for like, you can see like some of the code analysis we do. We have the mapping which shows like how the people are playing across the NHL game. So we do have a lot, but due to confidentiality, I'm not able to show everything. So let's talk about like how we manage all the security. Having like 1,000 users, 200 users on a daily basis, like how do we put the security management in place? For example, in Tableau, like we have a single sign-on in place. So anybody in the organization have the LDAP account, they can boom, they don't need to log into anything. They will just seamlessly, they will get into the site anywhere. This will give the opportunity to integrate the Tableau into any portal. We have multiple custom portal across the EA. Different studios have their own portal. We can integrate Tableau anywhere, at any time. As long as they have the access to the Tableau, then they can see it. And they don't have to log in any time. The next one is object level security. Like as I told, like we have a lot of game studios people. We try to make sure each and every game studio should be able to control their data. So if one game studio is working on something, it's very confidential that we should not share that with the other one. So we have a security in such a place that like in every game studios, we will identify a key person who will be the content admin of that particular group. He will control everything going on that group so that he makes sure when he publish anything, it will be provided to a certain list of people. Not all user groups are involved so that they can control the data. And the groups and they also, as I said, for any new project or any game studio, we'll create a groups, make sure the user belongs to that one. In that way, we can control it. Also, at the content level, we do the security. This is completely dependent on the publisher. So being an enterprise platform, we don't control anything. We give complete independency to the analyst. Like we don't have any developer in our company. All the data analysts, everyone, they're the rock stars. We make sure that our system is stable. So this security is completely dependent on the publisher. So we have a forum where all the publishers meet in a quarterly or every quarter basis to make sure like we evangelize like what was the good practices, best practices, so that you can control your own data. So all this will be defined by the project administrator. Each individual studios or any sub department, they will have their own project administrator. The last one is data level security. This is like a pretty cool one. Like we don't really have a user level security where like when the user logs in, they will try to get the data. We don't really have that one. So because we are more concentrated on the user level analytics on the gamers. So the database level access is something like if you publish any workbook, and if you want to control that certain people can access the data, you make sure you can either you can embed it, if you want to share that across the same group. If any particular group, let's say you have a Battlefield game group, you have 50 users in that. And if you want to make sure all these users will have the certain number of data, we will have the key member of that team will define the data for that particular group. And there are three options we will have it. Either one, we will prompt the users to put their login credentials so that they know which user is accessing the data. The second one is like we will try to create a data source connection and we publish that into the system, and only certain users will have access to that one. So if anybody wants to access the data, they won't see anything more than what the publisher has been defined. So let's see how we rolled out the platform at EA. So the key thing, as I said in the beginning, like we identified the key business people, like who want to do like the Tableau implementation, why they want to do, so that we can define like what their requirement, and facilitating the focus teams to cater each other. As I said, like we do have a forum every time we meet in the headquarters where all these key people will meet together to see like what's going on in Tableau, in what way they're having issues, so that they can cooperate each other. And as I said, even the centralized training. So we do have like every quarter or anything centralized training where we'll come up with a new feature to see like evangelize the thing, like how they can use the Tableau at the platform level. And also like these are the initial thing with what we do, like before they're going for any lives, we try to make sure that we have the post go live support in place so that we can provide them at least 2 weeks of 24/7 support. So if there's any issues, we will have a rollback plan in place if anything goes wrong. The next one is like infrastructure readiness. Supporting 100 users for more than 20 teams is a pretty challenging one. So we try to make sure how we make sure our infrastructure is ready for that. It could be from the admin with the Windows team or the Unix team or the virtualization team or the Tableau internal IT team. We try to make sure everyone are on the same page so that if something goes wrong, all the network team, all end-to-end deployment team will be on call for 2 weeks at least. So something goes wrong, we should be in the place to revert it within 10 to 15 minutes. And this process is pretty important for any company if somebody wants to build it at enterprise level. The process is very important because we try to give more control to the people, and it's scary, right? We don't know what they're doing. They can go and do anything. I have seen people uploading 1 terabyte of data extract. We don't know what they're doing with that. So this is pretty a common thing. Like we can't control it, but we should try to have the process in play so that we can educate the people so that they don't screw up the system at the enterprise level. So we try to get into that process chain, but there are scenarios like sometimes we can't control that. So that's a thing where I believe the Tableau is working towards, to put more control on how people can, control. Like if somebody wants to upload any data extract, we don't have any limitation. Like, okay, if some user is trying to extract like 1 terabyte, block it. We don't have any options like that. They can go and do anything they want. So we are trying to get into the scenario where we can control that one. I think it's a future request what Tableau is currently looking at. So let's talk about like how we have HA clusters. Like as I said, like what is HA? Like like everybody knows it's HA, high availability. What does this mean? Like being an enterprise platform, we need to make sure we have the data or the system running 24/7. So why we went for that? As I said, we had this deployment way back in 2012. And when we integrated all this silo system into an enterprise platform, the system used to go like every 1 hour. Every 1 hour it used to go. And I will talk more about that, why it used to go. So how did we implement it? I will be covering that in this platform. So let's see like what we had it. So for example, like way back in 2012, so we had like 8-core machine. So in that 8-core machine, we had more than 30 concurrent users running. At this time, the server used to go every 2 hours. So I'll show each and every stage, and I'll tell you like what was the cause in the next slide. The second stage, you can see in late 2012, we had two node high availability cluster with the 16 core. Almost we doubled it, and the user also got doubled in, and she started screwing up the same way. The third stage, early 2013, we had the 5 node HA cluster with 28 core. This is the pretty big. We thought that this system is going to be stable. No, we were wrong. So lesson learned. Let's see like what lesson we learned, by working for like 3 years. Then we are trying to stabilize the system. So we learned like, okay, let's go for a 64-bit platform. Like Tableau introduced the 64-bit edition recently, I believe, with the 8.1.5 or 6, I believe. So this will give the capability to run the multiple process. Like it uses the 64-bit concept, where especially in terms of memory, right? If you need to provide a best performance, even though you have a 64-bit Windows machine, and if your Tableau is running on 32-bit, memory is not going to use, it only uses 32-bit of memory. So you cannot utilize the resource available in the box, even though it's available at the Windows level. So that was the cool thing, like when they introduced 64-bit, that added a lot of advantage to us. So I will talk about that in the next slide, what exactly that means. So the key thing is we went for the distributed load approach. What it means is, like, I believe everybody in this room knows like what are the key components the Tableau runs on. So we wanted to make sure like we slice and assign this into different clusters within the system so that let them run on their own. If you put 3 quarterbacks in the same team and try to have them play, you can't do anything, right? So we are trying to isolate them into 3 different teams and let them run on their own. So we tried to isolate the background component because as you know, we have more than 1,000 extract. We decided, okay, let's isolate the background process. Let it run in their own system, in their own worker node. In that way, it won't compete for any resources between the SQL server, like the data engine server, all those kind of stuff. So we isolated the data engine and repository. Isolate SQL component. I will talk about that in detail next one. So monitor CPU and memory consumption. This is pretty important. This is very important if you're running at anything at the enterprise level. Make sure you monitor the CPU and the memory in each node within the cluster, because the CPU and the memory, these are the only 2 key factors which can screw up the system, and it can bring down the system. And sometimes you can't log into the box to restart the stuff. So putting the alerts, everything at the CPU and memory level is very important. So let's talk about so all these last 3 years. What we came across is like, for example, in 8-core single node, right? If you look at the system, like how the utilization at the CPU level, you can see gateway, it doesn't consume anything. Application, nothing. Repository, if you look at, we had everything running on the single box, like this. So you can see that data engine, backgrounder, and VSQL, these three guys are like super heavy duty guys. So if you put everyone in the single node, it's going to screw up the system. It will try to eat up everything. If you look at the data engine, it eats up almost 50%, and still it's want to fix more. What happens at the end? It will reach the 100%, the system goes automatically. It has to happen every hour. We don't know why it was happening. We took almost 6 months to identify why it was happening, because we wanted to re-engineering to see what each and every component was doing it. So then we came to know that, okay, this guy, we have gateway application repository, we do have a data server. I'm not covering because that doesn't impact the system. So the key guys is a VSQL, backgrounder, and data engine. Once we identified this one, we decided, okay, these three guys are they are pretty heavy duty components. Let's isolate them. Let them put it in their own there. Let them have good time there. So what we did is, so the next one we'll talk about the memory. If you look at the memory, the only component which is more vulnerable to memory is the VSQL server, because that's where the actual rendering takes place. So if you have more people, the memory will consume more. It will require more memory to render, if more than 150 concurrent users on the same box, at the enterprise level, trying to render the data, where you have the complicated visualizations, where people trying to interact, navigate within the dashboard, more than 200 users. Nobody knows what they are doing it. So we didn't know what was happening. So then we realized that, okay, VSQL server can consume up to 100% of memory. Even though you have, you can see it's an 8-core machine, we were having around 32 GB or 48, I believe, at the time. It was consuming everything. Let's see what happened to the distributed system load. So what we did is, since we identified all these, the critical components, we went with the distributed load approach, where we went ahead and isolated if you look at this one, we isolated the data engine, where you can see, I especially specified it as an rsync. So the data engine has two components, rsync and the data engine component itself. The rsync is the generic service. What it does is, in any high availability system, it will try to sync the data between the standby and the active data engine. So if you have too many extracts, in our case we have more than 1,000 extracts running every time, the system will become so busy that it will try to sync the data back into the standby engine. So if it try to do too many of those there is a chance that rsync can eat up all the CPU in the box, and it can bring down the system. So what we did is, we isolated that data engine especially to make sure rsync can use all the core available in that box, so that it can work on its own. And still, having the dedicated box with the single node data engine, still the system goes down sometime. The reason is, with the current Tableau architecture, we cannot have multiple data engine component within the same system. So you can have only one data engine as active and one as a standby. You cannot have multiple component like a VSQL, and the backgrounder, you can define multiple component of it. But for the data engine, you cannot control it. You have only one, and that one data engine has to support the complete load at the enterprise. That's what I believe one of the guy talking about the enterprise, they are trying to enhance the feature so that they can define the multiple component of the data engine level, so that all this load can be distributed across the component, so that the core, it can run parallelly. Currently, all the data engine, if 100 people are trying to use the data extract, try to render it, all these requests will come into the data engine and try to get that push data into the memory. So even though we have this top of the class distribution approach, still the system vulnerable to go down. We never experienced that. It's kind of a tips I'm giving you guys. So you can look at the next one is VSQL and backgrounder. You try to isolate all this individually in this different node, you will get the best performance. No matter the good thing about Tableau is with the 64-bit version especially, it's multi-processed and multi-threaded. So it gives an opportunity for everybody to scale it up by adding multiple nodes, so that you can add more components when it comes to VSQL or a background. If you have too many extracts running on a daily basis, you can have more nodes, or you can go for we are in a process of going for a virtualization pool. So Tableau can run on a physical node, or we can completely convert that into virtual VM machines. The advantage of going for a VM machine, we are currently working on building the pool. So that will help in such a way that if we keep monitoring the CPU and the memory utilization on the system and see like how it is performing, if we identify like, if we predict that system is going to consume so much of CPU or memory in certain days, you don't need to do anything at the Tableau, like at the deployment level. You don't need to go and add, install a new worker, try to reconfigure. You don't have to do with the VM. So you just, as long as you have a VM in place, you can add the CPUs to the machines. So it becomes seamlessly. In this case, what we did is we went with the physical node. We actually bring down the system and we added the new physical nodes. But when you go into the virtual VM technology, what happens is you will have a pool of resources available. You have multiple code, multiple memories available. The only way is you just assign that to the respective nodes. But the only thing is you need to make sure you will have a static IP for that. Because VMs, most of the time, it will dynamically change the IP. Let's see like how we have this system at the latest one is we have 48 core system. As of today, it's running. We are in the situation we might go into the 60s core pretty soon. You can see like how we consume the data. We have like market all leading database available. We use Vertica, Tableau, Teradata. We have MySQL, Amazon Redshift. We use a SQL Server. We do have the Excel. And currently we are working on the Presto exploration to see like how the vectorization will support, like being online data, we are trying to evaluate how it performs. And at the same time, we have like a Hadoop deployment. We don't have any third-party distribution. So we have our own Apache open source, so we are trying to connect that to Tableau. As of now, we don't have any native ODBC driver. So we are trying to see can we build a JDBC driver, or we can use one of the Autonetworks or Cloudera's distribution native ODBC connectivity to establish the connection. We are having pretty challenging time over there, so we are working with the Tableau to make sure how we can connect to this data. So if you look at our system, like we have 6-node architecture as of today. So we have a gateway, which is running as a primary and the secondary, and we have the 4 worker nodes where it is dedicated. So I will go into the detail in the next slide. So this is pretty common, like how the utilization is. It's like people will use it from everywhere, like portal, mobile devices, desktop. So let's talk about the internal architecture, like how we define the architecture. Like, so for example, like people will have access to the portal. Like, let's see what we did. Like we have the primary gateway server. You can see, right? The one which is in the blue, it says like it's a primary. The green one, it's a backup. It's standing over there. There is no automatic failover, and we made that automatic failover. I will talk about that in the next slide. So you can see that it's a VM machines. So gateway doesn't use anything. So it doesn't want it to waste any of our resource. So we went with the VM approach because the gateway it will take the request from the user and it will push down to the respective components. So if you look at the next slide, we do have the primary worker node. So if you can see here, like the primary, it's all active one here. So you can see the active data engine running and active repository. And we do have the application server. You can see with SQL and backgrounder as a single. Even though we are trying to isolate the things, we still have one of those components on this box. The reason, I will tell you next. So if you look at we replicated the same one to the secondary because anything goes bad with this one, it will fail over into this one so that we will have a complete seamless transition. It takes like 3 to 4 minutes for us to completely transition into the failover nodes. So similarly, if you look at here, we have the SQL server, we isolated that into a standalone where all the 4 processes will run. If you're running on 64-bit Tableau, you cannot run more than 4. So the advantage of having the vSQL, even though it's a 4-component, as I told earlier, it's a multi-threaded technology. Even though you have a 4-component, it will span into multiple ones. By default, it goes to 16 to 32 process, I believe. So even though it has a 4-component, it can support more than 100 or 200. You can define that based on the usage. Similarly, we did the backgrounder. Like if you have too much extracts going on in your platform, make sure you isolate that and make sure it uses all the resources in that. And you can see that we have complete 8 core dedicated to all the worker nodes, but our primary worker node has like more than 12 core currently it's using because we wanted to make sure the data engine can consume as much as core available on the box because the data engine is very heavy component where rsync will run every time. every minute it runs to try to make sure it will sync the data back into the standby. So any extracts refresh on this on the active engine, it will try to sync into the standby, always. So we try to make sure that we will dedicate. If you look at this one, we will make sure the active data engine will use at least 8 core on the machine, dedicated one. So once we go into the VM, we don't need to worry, monitor the CPU and memory utilization, boom, go and add it seamlessly, without impacting the system. Currently, it's running on the physical mode. So let's see like how the failover and, so as I said, in the data engine and repository, Tableau provides like by default, like if the data engine goes down, the Tableau product itself has built a method where it can fail over into that. We haven't explored much into that because it works what we were hoping for. So it typically takes 2 to 3 minutes for us to fail over into the standby one. The gateway server is the one where we try to make it more automatic, but as of now, the Tableau doesn't have ability where it can automatically fail the gateway server. So we have a script in a place in such a way that whenever the gateway server is not responding, we'll run that. The infrastructure, our script will automatically check the status in the primary gateway. If it is not responding, then it will make sure that it will activate the secondary gateway. So you can see as of today, we have the system like this. You can see SQL Server running, single node is running on each of the primary worker and the secondary. The reason why even though we wanted to isolate the components in its own box, if you look at the active worker node, we still have one of the SQL Server, even in the active as well as in the secondary. The reason, let's say if one of the node, the third node on the left corner is having 4 components. Let's say if it goes down, what happens? You don't have anywhere to go. It's a complete shutdown of the system. So we wanted to make sure that we are ready for the disaster recovery. If anything happens at the isolated node, we still have at least one component at the active and the secondary worker node. So in that way, at least we will have something to make sure the system is up and running, even though one of the workers who it completely handles the SQL is down, still we'll make sure the system will be running. So that's one of the reasons we added that one. And as I said, application server, it doesn't consume much of the thing. It does only the browsing and the permission of things. So we don't really worry about that one. So as you see the background of task, anytime it shows the same status. It's always in the mode of refreshing it. So you can see your data engine and repository. I was talking about like the active worker server will have both the data engine as well as the repository in the active mode. You can see in our system, it failed over into the other one. The reason is, it can happen like, we need to make sure whenever we have all this Tableau system runs on Windows machine. So we need to make sure like when we work with the infrastructure or admin team, they tend to run all these updates automatically. Sometimes it will refresh on their own without telling like us. So since all the systems running on Windows, like last month, like the system, one of the node went down without any alert from us because there was an update was running within the system and it shut down the system automatically. And this one came back in 3 minutes. And you can see the repository, it filed over into the secondary one. So if you see the data engine, one of the active data engine is running on one machine, the active repository on the other machine. This actually will provide the better performance at the enterprise level. The reason is when you configure the high availability for the first time, there is no way you can go and make an active data engine in one node and the next node will be a repository. By default, it will take both the component as active in the first node itself, where you define it as active one. So when the system goes down, the load will automatically go into the secondary one in this case. So even though repository doesn't consume too much of memory, if it is running on their in its own different node, that will be a good thing. In this case, you can see data engine repository is not running on single node. So this will be better rather than having both the components running on the same one. So the next one is like a backup strategy. What are the backup strategy we have? So as usually everybody knows that everyone take the TS backup. So we take the backup frequency twice a day, fully backup on the weekly basis. It depends on the company, like how important the data is. You can make sure like you can take the backup every hour, it depending on the key data, what refresh what time you do. If something goes wrong, like which team is having more impacted so that you can plan accordingly. to take the backup, so that if any time you can restore that. The third one is like backup tab SVC and the workgroup YML. These are the two key configuration file we need to make sure we'll keep a backup of this one, especially in running on HA environment. Because if you make any changes to the HA environment in the main gateway server, make sure you have a copy of that, so that if something goes wrong with the gateway server, it will fall over into the secondary, where the configuration configuration being in sync. Otherwise, the system will show the incorrect information, saying that like, for example, if you added a new SQL server, and if you forget to take the backup and you restore the failed over into the secondary gateway, you will be missing that SQL server. So to make sure everything sync and able to fail over within 10, it takes 10 minutes for us to automatically fail over into the secondary. So the logs, as usual, we take the logs on the weekly basis to make sure like if anything goes wrong, we will have the weekly backup so that we can work with the support team. We do the cleanup so that we get rid of all the HTTP requests, all the temp directory contents. We have the script running so that it will clear all the logs. Scheduling, we have the Windows task scheduler, which will kick off all the scripts for monitoring, taking the backup, cleaning up the directory structure. And whenever we take the backup, like we try to push that into an archive location where we define like how many days we need to keep that, so that we'll clean that accordingly. As of today, we have more than 45, I believe it's 42 GB of extra, TS back file every day. It takes more than 1.5 to 2 hours. Yep. So let's say like how do we have a monitoring in place? So we have a CPU and memory utilization at node level. So being a high HA system, we have a script in such a way like it will identify this consumption of CPU and memory in each and every node within the cluster. So for example, you can see the sample script, right? This one will check like, it check the rsync CPU process time. So rsync is the key contributor for us, like it can screw up the system. We try to monitor like how the rsync is working. Is that taking up too much CPU or not? If it is taking, we do have a process in place where it sends alert saying that the system is trying to consume too much. Similarly, we have the working set, it's a memory. Like we try to see like if some of the component trying to eat up too much memory, we get the alerts, and sometimes we have the script where it can go and kill the situation. If trying to consume the system and try to kill that. And the next one is we do have a thread level alerting in place. The thread level is like, as I told earlier, even though the Tableau as the individual component, for example, VSQL and data background server, on the PGSQL, all this having the individual component, but still it will span multiple threads. So as I told, it can scale up and scale out. So when it scale out, we will try to make sure like how many threads are running and what level, like at what level system can consume more CPU, so that we can define how many threads a component can consume it. So if you have a VSQL server and if you define by default a 16 process, and if the 16 process is trying to eat up most of the thing, we will try to make sure like we don't allow all those 16 threads, we try to reduce that. Or we try to add more core so that we can increase that capacity. So we are always try to increase it, we never went back. So these are some of the sample script we have, which can talk about that. So it checks if the thread level is nothing but if any thread, there is no thread available, it means the system, one of that component is down. At any given time, if it is a VSQL or a backgrounder or a data engine or a rsync, at any given time, it should have at least one of them. Means if the thread count is less than 0, there is something wrong with the system. Even though we have a multiple check at the system level, we have 3 to 4 layer of alerting system in such a place. Even though we have a 24/7 offshore team monitoring the system, we have automatic alerts so that we can support it, even without any manual intervention. So we do have a third-party monitoring tool on top of our own in-house scripting. Like being enterprise, I believe most of the team will be enforced to use the enterprise level monitoring tool. We do have that one. So that will actually monitor all the components you can see over here. So any of this service goes down, we get the alert saying that this component is not running on this machine. If we are not reachable in 5 minutes, it will go escalated to the next level. The next one is authentication. So as I said earlier, like in Tableau, like we do have a single sign-on check. So the disadvantage of having the single sign, it's not a disadvantage actually. So sometimes it can fool the IT team, because having the single sign-on, we have to depend on the LDAP servers. So if the LDAP catalog is down, we don't know whether it's an issue with the LDAP authentication or the server. Because when the user logs in and if the LDAP server is down, it will show that this application is 500, HTTP 500 error. So everybody think, oh, something wrong with the server, wrong with this platform. But what we do is we need to make sure the first time when somebody says, oh, I'm not able to log in, we will try to make sure the LDAP servers are up and running. So if there is any outage at the enterprise level, we do get the notification saying that LDAPs are down. Because LDAP is like Active Directory is the key component for any enterprise. If the Active Directory goes down, all the applications will go down. Because if you have a single sign-on, automatically without knowledge it will go down. So we need to make sure, we try to make sure the single sign-on is working. If it is not, then we will identify, okay, it's an issue with the LDAP, so nothing is required on the Tableau side. In that way, we will try to isolate so that we don't have to spend unnecessary time, because we went through this one for a 6-month period without knowing what's happening. Because we were trying to identify the system was up. So what we did is, even though the system is not working at the browser level, as an admin, you need to make sure you get into the box and try to log in there. You will get a different notification there. You don't get a HTTP 500 error. You will say that the Active Directory is not working or some different message. And also, you can run the status of the system and see, like, is that really something wrong with the system? So you can use tab admin status -v, which can give you each and every component, whether it is running or down. It will give all the information. And also, at the same time, you can check the data extract file in the active and the secondary node to see how the rsync is working. Is that really syncing the data? If you see the data is syncing, it means the system is working. There's something different. So you can see all these logs and get used of it. The last one, not the least, we do have Tableau app admin status. This is pretty common one, like where you can use the maintenance page and see how it is behaving. And we do have a URL check on top of the single sign-on. We do have a URL check to see if it is not equal to 200, there's something wrong with the system itself. So we do have this multiple layer of alerting system in place. Even though the thread goes down, even though one of the components down, LDAP server is down, even the HTTP server is down, it will send us the alerts. So this will give us more visibility into each and every component at the enterprise level, so that we can stabilize the system. So you can see that we do have the first one. I think I missed it. So it's monitor service status. It's check the status of the server every 2 minutes to make sure the server is up and running. If it is not running, we'll get the alert saying that something is wrong. And most of the time with the Tableau, there is a chance that there is a timeout between the command you submit and the time you get back the result. The most of the time, if it expires, it will show that system is down. So nothing to scare. Actually, the system will be running. So immediately we have a security in place. Within next 2 minutes, it sends an email saying that it's up and running. So let's say how we build a single sign-on. So Tableau being a Windows platform, since they are not into Linux as of today, it was pretty easy for us to build a single sign-on, because so at the enterprise level, we do already have the LDAP servers available. So since it's a Microsoft Active Directory, it's pretty easy to authenticate and integrate the single sign-on, because Tableau runs on Windows. So Windows Active Directory, it's easy to implement. So we never had too much of challenges, except, as I said, EA being the global company, we do acquire a lot of studios. So all these studios will have their own domains. So we do have multiple domains across the company. So it was a challenge for us, like if you have one particular employee who belongs to different domain, X domain, the other guy will belong to Y domain, but if you try to add them into the system, it's a challenge because the Tableau cannot identify. So we had those issues in the beginning. So what we decided, if you look at the right side on the picture, you can see the root EA domain, right? So we defined it within the Tableau server to make sure it always, the the parent domain. Let's put it in this way, the parent domain. If somebody logs into the system for the first time, the application server will send the request to the LDAP server, which is the root EA domain. It will go there, authenticate whether this guy is, it will try to check, is this user available in the EA domain? No, it will go to the child directory, try to authenticate, try to navigate and see where this user is available. So we have all this Active Directory in a parent-child directory fashion, so that if you enable the parent Active Directory at the server level, it will automatically go and search within the catalog to see where in which domain it belongs to. And the challenge with that is, even though you have all these domains, sometimes the Tableau doesn't recognize the domains. So it will say, oh, this domain is not in the repository. So we do have that issue earlier. So what we did is, so we actually went into the repository, we added the domain. So you can get into the PGSQL database where you can make an entry of the domain. You can define the new entry for that, and then you can add the users automatically. That's one of the things people can get into. So let's say, like, what are the tips like for server stability? These are, I think I already give some of those. So as I told earlier, go for distributed system. Always try to isolate all the components. Let it run on its own, and keep the minimum thing running on the active on the secondary, just to come out of the disaster. As I said, reserve 8 GB memory for each vSQL component. So this is pretty important. This is the minimum requirement to make sure at least you have 8 GB of memory for vSQL component. You can have, if you have 4, it should at least have 8 into 432 at least. It can go more than that because we are into 64-bit Tableau architecture. It can consume more than that. So you have more memory, it's better for the system. Reserve 2 core for each backgrounder. So make sure you're running backgrounder. It can eat up all the CPU. So make sure you have at least, if you're running on 8-core machine, we have only 4 backgrounder running. It means that at least it will consume only 2 core of the resource. Most of the time it can, it's not like a dedicated core, but we will presume that it can take up to 2 core, but it can eat up almost 3. One of the component can eat up all 4 cores. So that's the reason we may try to maintain the CPU and the memory to say how it is behaving. The next one is disable Windows operating system updates. So since we are running on Windows machine, we need to make sure all the updates are disabled. No automatic restart of the system, because this does happen a lot of time. Like without knowing the Tableau team, updates will be automatically shut down. Nobody knows what time it shut it down. So make sure we will have this disabled so that we can control that and plan accordingly and do the outage. Keep tab service to manual on each node. This is something very important. Like so in any Tableau, since Tableau running on Windows, so it does has a tab service component running in the service manager. That's the one which will make sure the server is, that particular node is responding or not. So if you make this service as an automatic, even though your gateway server is down and by default someone restarted one of the worker node, there is a chance that data, if it is running on the data engine, the tab service will automatically start, even though gateway server is not running. So this might screw up, saying that the data engine will automatically try to come up, like running and try to screw up these things. Like it try to go see what extract it can run, so that there is no gateway server is available. So there is a chance that it can screw up the extracts. It indeed happened to us. So that was the very key things. So monitor, as I told earlier, like it's better to monitor the thread counts so that we can define like how the load on the system. Monitor, this is being at the enterprise, this is pretty cool, I mean, pretty important one, like monitor usage of workbooks and archive strategy. So you need to make sure like how the people are using, the Tableau itself provide out-of-the-box usage reporting, but you can build your own custom to see how the usage of each of this group and how they're utilizing the bus, so that you can have the cleanup and archiving strategy in place. So in that way, we can keep the enterprise platform up and running all the time, even though where people will be consuming all the time. So if something is not usable, you move that into archiving. The performance. Use extractor, like these are some of the things at the admin level where you can evangelize to the team, like, okay, you please try to use the extract, if possible, try to use the incremental extract so that it will reduce the response time and improve performance. So schedule updates. We try to do this one, but it never happens. So avoid publishing the download workbook during the peak hours. We try to evangelize, make sure you don't upload or download when people are trying to run the render of the system. So because the resource consumption could be more. If you try to upload there was somebody trying to upload 1 terabyte of workbook, it might screw up the system. Enable cache. This is a pretty the old concept what we had, and I believe one of the guy today, I think they told they're going to do the persistent caching. So we will be exploring more on that one. So this was the caching was good with the live connection one. The other one is like the context filter. This is pretty simple one, but most of the users are not aware of this one, where like user can have the context filter so that they upfront it can filter the data, and most of the time it will materialize as the things. If you are having multiple tables in the workbooks, up on the fly it will create a materialized view so that everything will be sourced from the single table. When the WSQL creates all this, when there is a request comes back, the WSQL try to render the data. When you have the context filter and you define what data you want to see and enable the automatic updates, it will create its own materialized view within the Tableau, so that instead of hitting multiple tables, it goes into the materialized view and it renders the data out of that. Failover and recovery. So how to confirm failover gateway configuration? This is the pretty good one. Like we were trying to, when we configured the system, there was no way like we can identify like, is that really the gateway configuration was done? So what we did is like, there is an option in the node itself, like only in the worker node, where you can go to the Tableau administrator server. That's one of the service running. So you can check the properties of that service and see how the failover is defined there. There you will see the primary and back, primary and the standby node defined, the gateway one. So that will give you a confirmation saying that, okay, whatever I've defined as a failover for the gateway, indeed it's available. The other one is restart worker nodes only when the gateway server is not running. So when the gateway is running, make sure you don't do anything. Even though one of the node is down, don't try to restart that one. Keep latest version of tab sync and workgroup. These two, YML tab service will keep the configuration of the HK system, and the workgroup will keep all the tab config. If you are configured to increase the background or timeout or a WSQL timeout, the number of threads, so you need to make sure you take a copy of that workgroup YML so that when the gateway failed into the secondary one, we should be able to have the same configuration up and running. So when the primary gateway goes down, we do have a script in place where it runs all the script to move the secondary as a primary and sync the tab service and workgroup YML so that it will become a seamless one. Have failover script ready, as I told, ready to sync backup gateway and config changes. Use VIP or DNS to point to the backup gateway server. This will give the seamless transition if anything goes with the gateway. The reason is like if you have a dedicated static IP as a HTTP address, it might screw up the system, because if the server goes down, the user will be having there in the shortcut as their static IP. And if you failed over into the secondary gateway, that will have a different one. So that is not a seamless transition for the customer. The experience will be bad. So we need to make sure we will have either virtual IP or DNS in such a way that you will have like tableau.com. That's it. No matter what happens under the ground, for the users, it will be tableau.com always. So it will provide a seamless server upgrades. So like we did, like we moved from version 7, now we are in 8.1.6, I believe. So what we learned is like after installation, like configure distribution with default repository. The reason why we are saying default repository is like when you upgrade or when you upgrade for any new feature, you don't need to go and update the metadata when you actually configure the node for the first time. So you go ahead and completely build the HA system. Either you add a 5 node, 10 nodes, it doesn't matter. Build everything in one shot, and then at the end you restore it. This will reduce a lot of heavy duty process, because when you try to do it at the active server and when you try to configure the secondary one, at that time it will try to sync the data instead, rather than doing it at the end. So make sure you do the default repository and then restore the latest one. That will take automatically it will give more visibility to the Tableau system so that it can sync the data between active and the standby or like within 20 to 30 minutes up to 1 hour. It depends on the size of the Tableau extract, TS back. So restore backup with, as I told, make sure you will restore the backup with no configuration. If you try to do the configuration, if you made any changes, it might screw up the thing. So make sure you don't do the configuration, because at the first time when you upgrade the system, you have all the configuration already in the place. So don't try to get the configuration details from the TS, the backup file, because there is a chance that it might contradict what you have currently. So make sure you do the restore with the no config, because the configuration is already in place. You just need to restore the data, that's it. And also run script to sync the workgroup.ym, as I told earlier. So you need to make sure the workgroup YML is in place, because the reason is like when we had these issues where backgrounder was like, by default, I believe now it was 7200, earlier it was 3600 seconds, I believe. So when we didn't sync this settings, we don't know what we changed during last 1 year when the old version was running. So we need to make sure all those configurations are backed up in the YML so that you can run the tab config command so that you can sync all the settings, so that you don't have to miss anything. So some of the dashboard tips, this is the final one. So some of the basic dashboard we have here, like we try to do like choose right data to present. Like it could be a combination of the graphs or the data. So this is one of the booking data what we have. You can see the games, Battlefield, FIFA, some of our top titles. So this is the dashboard, like where this will talk more about like customer, how the customer is providing support to the games and how the utilization. This will tell like how visually it can make more sense rather than looking at the numbers. So we do have a lot of other dashboard, but due to confidentiality, we cannot show most of them. So, and the bad thing is it takes a lot of time to fudge the numbers. So, and you can look at this, make it more interactive. Like if you look at this one, this dashboard will give more interactivity to look at each and every customer support representative, how he is interacting with the gamers, and how he is providing the service to the gamer. And this will help us to see how the utilization of the customer support representative, and also it will help how in what way we can provide the support to the game so that we can create a better experience to the gamers. That's it. Any questions? Go ahead. We have more than 300. Yep. Yeah.
As far as like depth, making sure kind of the right knowledge is built out around the data itself, is that a studio level thing that's built out, or do you have control of that?
Can you repeat that?
Oh, sorry. So as far as like the data cleaning process is
Mm-hmm.
concerned, as far as understanding data for people at level, is that something that's built out at the studio level? Do you guys advise that?
Yeah, we try to make sure that in what way they can use it so that the Tableau can perform better. We try to evangelize to each and every game teams, also at the marketing and on the different online team to make sure like in what way you can have the data in place so that you can have a better performance. Because if you look at our architecture, it is we pull data from everywhere. Right. So we try to evangelize to make sure that whenever they pull the data from any source, it won't impact our system. They will be in charge, but when it comes to the enterprise, we will try to do that one, because as a IT organization, we do support our enterprise data. So if anything at the studio level, the same data will be available at the enterprise level. So we try to control that one. So in that way, we will make sure that we provide the right data for them, so that the performance, indexing, all the database level features, everything is in place. Then we will try to evangelize, make sure how on the Tableau side, you can have the better workbooks created so that it can perform better. Any question? Oh, what is that? So the logs, like, before taking the backup itself, we will clean up the logs. So when you do, yes, you can do that. So what it will do is it will clean up all the HTTP which is not active, the HTTP request and all those. It will clean up the one which is not active. If something the HTTP request is active, it won't clean up all those things. So it will try to clean in the last 7 days what was the inactive session logs. It will try to clean up all those things. So that's the reason, like on the weekly basis, we do the maintenance so that we can clean up everything when the system is down. So, any question? Yeah, I'll meet you. Any other question?
Yeah, I just had one question. So, we don't have nearly as many workloads being refreshed in the background as we do, but we have about the same number of current users, and we haven't really had the same scaling problem. So I'm wondering if you guys have tested keeping a lot of the data in its source locations versus letting people, count 1,000 extracts on the server.
Yeah, so that's a pretty. So we do have a lot, since in our system we do have a lot of data extract, sometimes it's an overhead on the system too. So we try to work with the team to see, like when they try to upload the extract, we try to see what would be the utilization of that one. So if it is not utilized for more people, can you guys hear me? Try to make sure like either make sure we go for live connection or extract. So if the utilization is more, there is a tend to get a lot of session back into the database. We try to evangelize, okay, create the extract. And most of the thing is like, let's say in a given workbook, if you have a multiple data source, and like most of the time user, what they will do is they will upload the extract and try to set that refresh. Instead of that, we are currently working on this scenario where we are trying to upload each data source into the server and schedule that to refresh. That will reduce the limitation on the number of workbooks. If the 100 workbooks are using only the 5 data source, you don't need to keep on going and refresh the same data source for each and individual workbook level. Rather than you upload that into the data server and refresh that extract at the data source level, if the same data source being used for multiple workbooks, the refresh will be automatically reflected into the workbook. This will reduce the overhead on the backgrounder, and as well it will increase the performance on the system.
Yeah, that's where our optimization is most likely headed in the short term.
Mm-hmm.
There's not enough sort of reuse across all these multiple systems.
Yes. And also most of the time, like data extract also makes a key contribution. Like if any particular team are interested in certain data, you can have that extract created and upload into server, and don't provide any connection to any of the database, so that they won't have access to the database so that they can upload anything. Rather, they will use the extract available in the Tableau, and then they work on the workbook. So that will also reduce the number of people trying to create too many data connections.